Welcome back to Daily Maths Concepts. Today, what we want to look at is the displacement of two position vectors. Just quickly, some persons might want to ask what's a position vector. So a position vector is definitely one of those vectors that would have a specific starting point. And normally we use the origin as that starting point. We call it O. So definitely the origin is the starting point right now. So the vectors would have that common starting point. So everybody starts at O, or the origin 0, 0. So in a position vector system, as you could see, if you look at the point D itself, just the point D, you would have realized that the coordinate for the point D is a -2, 4. So -2 on the X, 4 meets right there at D. If you look at the point, so that's D, -2, 4 at D. If you look at the point B and C, we could see that the coordinate of B is actually 2, 5. The point B, just the point B, the coordinate of B is 2, 5. And we're seeing that. And the coordinate of the point C is actually 6, 1. So if we look at the points itself, then we have these coordinates. When we're looking at the position vector, we're talking about, remember, the vector is actually just a line segment connecting 2 points from 2. So from the origin to D, if you look, we have this OD as a vector. You would have traveled 2 places to the left, which would have signified the -2, and then 4 places upward to D, and then you would have -2, 4. So as you could see, if you should observe this and observe that, those are the same numbers. All right. So technically, the coordinate of a point in a position vector system, all right, is the position vector when you're ready to deal with the position vector. So the position vector of OB, let me put it beside it, OB, let me write my arrow a little better than that, right? So the position vector OB would be 2, 5 coming from the coordinate of the point B. The position vector OC is 6, 1 coming from the point C. If you want to double check, 1, 2, 3, 4, 5, 6 places to the right and 1 up. Hence, +6, +1. So we have our position vectors. What we want to look at is how do we displace two position vectors? So for example, if we're asked to find DC. So basically we want to travel from B to C. Right? So if we want to travel from B to C, so our arrow would be pointing in that direction because we're heading that way from B to C. Now, technically, if I'm on a graph, I could easily count this. I could use my graphing and understanding head and tail. I'm moving from B to C. Then I would have moved 1, 2, 3, 4 places to the right. Then 1, 2, 3, 4 places down. So it's +4 and a -4. And definitely I would get there. So that is my vector BC. Graphically, I can do my quick check on the graph or how to displace two position vectors. There are a number of ways we can get there because remember, the vectors are connected through the origin. So B and C, they are connected through the origin. So we're going to look at 2 ways. One way in which we could find the vector BC is that we would be moving from B to O, which is the origin. Then we leave the origin and go to C. So technically, we are traveling like this from B to O and then O to C. We would be moving from B to O and then O to C. And then we would have accomplished that movement from B to C. Now, let's look at the system. B to O. We got OB here. but now we want to go from B to O. So definitely we're going in the opposite direction. So we're going to come from B to O and then travel from O to C like that. So the direction would have made a big difference. So B to O would have been -2, -5, because we're going the opposite direction as OB. And we're going to be adding OC as is. So we're going to be adding OC, which is 6, 1. So when you add this, -2 plus 6, -5 plus 1. And this gives us +4, -4. And we knew that. I was just saying that we knew that by what we did first. So there it is. We were able to come up with our displacement of 2 position vectors, method 1. So this is like solution 1, how to displace 2 position vectors. But definitely there are other ways to displace the vectors. So we're going to displace them using method 2. So I'll just call this solution 2. So if I want to displace 2 position vectors, I could simply say this. Let's check it out. We're moving from B to C. So if I'm moving from B to C, I need to have the position vector OC, and I use it. So it's going to be OC, and then I'm going to take OB from it. So that's another way. If you notice, the C was last, I'm using the position vector for that first. The B was first, I'm using the position vector for that last. So basically, it's that the last minus the first. So OC minus OB. Let's look at what OC is. OC is here. Let's check out OC, 6, 1. So OC is 6, 1. And then I'm going to subtract OB, 2, 5. So let's do the math. 6 minus 2 at the top, and then 1 minus 5 at the bottom. What do we get? 6 minus 2, that is 4, and 1 minus 5 is -4. So you could see we got the same response. Here it is. Here it is. And that is why we say that we got 2 methods when you're not on the graph. When you're on the grid, though, you have 3 methods. 3 methods. The one we did first and these 2. So we just displace those position vectors right there. Right. Now, let me take off one of these methods so that I could just employ some working. Now, what if the question wants us to find the magnitude of BC? So it would be written, we want to find magnitude of BC. So the magnitude of BC, remember, to find the magnitude of a vector, we definitely use this. So if we have a vector OA, which is x, y, the magnitude of the vector OA is given by Pythagoras theory. X squared plus y squared, we take the square root, and this is going to give us the distance. The reason for that is the vectors, as you could see, would make, if I'm using OC here, if you could look, the vectors would make this right angle triangle, where 6 would be this leg and 1 would be that leg. So technically, the vector is like the hypotenuse, and I'm finding the distance of the hypotenuse, where it's going to be the square of the 2 shorter sides. So that is the principle being employed here. So then, having had the components of BC, we're simply going to use Pythagoras theory. So it's 4 square plus -4 square, and then I take the square root. Both of them, I'll get 16 plus 16, and then I'll get the square root of 16 plus 16, which is 32. So this is the answer, 32 units. But definitely, if I'm writing that in decimal, about 1 dp, I'll have 5.7 units would be the magnitude of BC. All right. So that's the magnitude of BC there. And so what if we were asked to find the angle that BC actually makes with the x-axis? Because every now and then they want us to look at the angle that it makes, right? Not BC, I mean OC. Let's just look at OC right there, all right? So we want to find the angle that OC makes with the x-axis. Let's check this out quickly. So this is OC. The angle that we're talking about is right here. Basically, we're getting our right angle triangle here. So let's walk the right angle triangle. So you could see, so my line is not perfect, but so we would get the right angle triangle here. As you could see, this side is 6 and this side is 1. Now, the angle that we want to find is this angle right there, because the vector angles are always like that. So we are saying that applying the soccer tower, right? We would have used the tangent. So definitely you're seeing the tangent of the angle that we're referring to is equal to the opposite side over the adjacent side, which means the tangent of theta is equal to 1 over 6, right? So the tangent is the opposite side over the adjacent side, which is 1/6, which means to find the answer, we need tan inverse of 1/6, and it's going to tell us that angle that we're looking for. Now let's drop that in. Make sure our calculator is in degree. And let us say I want the angle to 1 dp. I'm looking at the angle is 9.5 degrees. So very simply, this angle right there is 9.5 degrees. So that is the angle that the vector makes with the x-axis. So technically, for a general formula, you could see then that, let's just pull it aside a little bit. All right, so we had an idea like this, and I had 6 and I had 1. So what we're saying is, basically, where the 6 is, this is my x value and the y. So this is the y value and this is the x value. So for a general formula, the angle that we're looking for, because is going to be y over x right there. So then what we're saying is tan inverse y over x will always give us the angle that the vector makes with the x-axis right there. All right, so that's the angle that it makes with the x-axis from a general point of view. All right. All right, thank you for watching. Please like, subscribe, and drop a comment. See you next time. Bye-bye.